Hey, do you hear me? I hear you. Do you hear me? All right. How are you? I'm okay. Sure. Yes. Let's see. This is a different program, right? I did. Let's see. How can I do that? It says that my end says that you're able to show. Let me check that. Still not letting you. Let's see. Let's see here. Allow. It says you're the host now. Can you share it now? I'm not sure what happened there. Alright, I get, yeah, clearly. Okay, so this is your first quiz. Okay, how'd you do on the first one? That's good. That's good. Okay. So does this have a graphing function that lets you graph that equation? It just wants you to well, for those, I guess, I mean, you could plug in those values. You could plug in -3 and see what you get, and you could plug in -5 and see what you get. Graphing tool to graph the function. So if you're looking at that, if you plug in -3 in the absolute value, that gives you 0, absolute value 0. So that's 0. I don't know if you want to like plot that point. Does it let you plot that point? So -3 for x would be 0 for y. So that's 3. You want to go -3 right there. So I'm plugging in because it's saying find the limit as the line approaches either side from -3, and then if you plug in -5 in there for x, that gives you -15 plus 9, which is negative 4, which is absolute value, which is 4. So the other point will be negative 5, positive 4. Can you plot that point? Because that's okay. Maybe you didn't. Oh, maybe. And then if you look, the limit as you're approaching negative 3 and negative 5, the y value is the limit there. So if at that A1 there, the limit of negative 3 from either direction, that would just be 0. And then negative 5 either direction, that would be 4 for that one. I'm not sure. I mean, that's just that part of the graph. I don't know what other part of the graph you plot. Does this quiz give you like instant feedback? Does it let you know? It does at the end. Okay. So how many questions? 3? Okay. It's kind of weird, huh? Okay. And then the lessons, were you looking at the lessons at how to do some of these, or do you look at videos or anything? Or? But you're only okay. It is. It's just starting to get into calculus concepts where limits is the first one where you're looking at graphs and approaching the graphs. So look. Because you're looking at that graph as the graph, the limit of g of x as you're approaching positive 3. So if you find 3 on the x-axis, graph find, select the right choice. Let's put that in Desmos there. X squared minus 3. So that's definitely choice B on that one. That's choose a correct graph. So that's the correct graph. So that one. And then so you're looking at that graph. Can you make it bigger? Hit the zoom button on that. So if you look at positive 3 on the x-axis and go up and hit that line and then look over at the y-axis number, that's your limit at 3. So 3 on the x-axis hits that red line and looks like you go over and hit the y-axis at 1, 2, 3. Is it 4, I believe? So do you see your pointer? Can you put your pointer on positive 3 on the x-axis? Right, one more dot, there you go. And then go straight up and hit that red line. And then look to your left and see what that number is on the y-axis. What is that? Is that 4? 1, 2, 3. maybe, yeah, my graph shows 3, 5, no. Yeah, that's better. One, 2, 3, 4, 5. Yep. 1, 2, 3, 4. So that's your limit as your line. So that, do you understand what that means right there? That little arrow X pointing to 3. That means that red line, you're trying to find the spot where if you come to the left and the right on the x-axis and they meet at 3, that spot on the y, it's kind of confusing. But what you did to go over 3 on the x-axis and then go up and hit that red line, that's the exact spot. That's where the limit happens. On that video that I sent you, I don't know if you're able to look at that, but that video link, it explains limits super easy. I don't know if you have a few minutes ever to watch that, but it makes more sense. So then blow up that graph even more. Same graph. So now you want to do it for +2 on the x-axis. So if you go over 2, and then go up, and it looks like 1. So that's your limit at when the red line approaches 2 on the x-axis. That little spot right there corresponds to 1 on the y-axis. That's your limit. It's kind of confusing, but all right. I have 3 questions. It wanted you to graph the whole thing. I guess, and then looks like we missed that limit number right there. We put 6, put 4, -15. Oh yeah, that -15 plus 9. Yeah, that's 6. Okay. Does this let you like redo these quizzes, or what happens on these? So you better do all 4. So we gotta redo this one? Yeah, let's redo this one. So you passed 1 already, and then you need to pass 3 more. Shouldn't be too bad if there are 3 question quizzes. On the quizzes, okay, do you have unlimited tries on the quizzes, or does it penalize you when you redo? Do you know? Maybe. Okay. Okay, so we could do the whatever one you want to do. Graph linear functions. So you got to do 4 total. Okay. We could do, sure, we could do the practice piecewise, and then we could do that quiz real quick, because those are pretty easy. I could see it, yep, for sure. Actually, no, I do not see, all I see is that original screen. Did you click on anything? I can, yes. So you got 1/3 x plus c negative x plus 10 x less than 3. Another one is x more than 3. Alright, so I'm going to use Desmos to graph those two. One-third x and then determine, let's see. Wow, does this have like an explanation or anything, or does it show you? Alright, see, what does it show? That's okay. I got you. There we go. Sure. Yeah. This new software, a little confusing, huh? That's about as busy as it gets. Okay. That you could hit continue there, I guess. So it just says you're talking about limits coming from the left and right of 6. First find the right limit. Negative x should be used. Okay, let me write down those problems there. Okay, so they're looking at the limit from the right, so this graph, more than 6 coming at it from the right side. Okay, why don't you go to continue, see what they say. So they're plugging in 6.1, 6.01, 6.001. Take a picture of that. Hey, go up a little bit. Does it scroll down? Okay, I see what they're doing. They're just adding more to it. All right, you continue. So approaching it from the left. Okay, you can hit continue there. So doing some tough math, plugging in let me see my calculator there. So 1/6 times 5.9.983 5.99. Wow, this is complicated. I guess so. It happens when you start taking that calculus class. Ooh. And then 999. But it looks like this software is pretty much like Alex kind of explaining as you go. Okay, you can hit continue there. 6 from the left. 1 plus C. Okay, that makes sense. Set the left and right limits. Solve for C. Alright. Continue. Alright. Do you want to try one of these? Alright. This is the practice. Alright, so I'm going to write that down. 1/2 x plus C negative x plus 7 x less than 2 x. No, I'm not going to use Desmos. So that little x less than 2, so that means I'm going to plug in 3 numbers less than 2, so I'm going to plug in 1.9, 1.99, 1.999. And then for the limit for coming on the right more than 2, I'm going to plug in 2.1, 2.11, no, I'm sorry, 2.9, 2.99, and then 2.999. I don't know if you can see my work that I'm doing there. Make that even bigger. Yeah, I forgot in that example. When that example did more, I forget the numbers they chose? Do you remember? Was it? But numbers more than 2. I wonder if is it 2.1 they use in 2.1? I'm just going to use 2.9. Does it let you go back to the practice? Alright, go back to that practice real fast. Let's see. So that would be 2.1, 2.01, and 2.001. Alright, there we go. Thank you. So now I'm going to plug in. Right. Thank you for helping me with that. And then if I take that 2.1 negative plus 7, gives me 4.9. If I take negative 2.01 plus 7, that gives me 4.99. So it looks like my limit's approaching 5. Negative 2.001 plus 7. So I'm doing all this on my calculator to get those numbers. I'm not sure if you're seeing these, but definitely approaching 5, right? So that's the limit from the right. I'm using this one. Yeah, it's really basic. I like it. It's real tried and true. And then if I take that top one and take 1.9 and plug it in for x, so 1/2 times 1.9 gives me 0.95 plus c. Plug in, let's double check that. Yep, so I plug in 1.99 times 1/2, that gives me 0.995 plus c. So I'm just plugging in each of those for x, and this one gives me 0.9995. So it looks like this is approaching 1 right here again, kind of like that other one. So I think they have you write that as 1 plus c. Then you set these equal to each other. And remember how they had you solve for c right there? I get a 4. Yes. So if that's the way the practice one is done, try that. Yes. So probably don't want to take time to do a similar one. I want to jump right to that quiz. It looks like it's letting you do a similar one to practice again, which is kind of cool, but so let's jump to that little quiz, that piecewise quiz. I bet we could do those for now. That's not it. Oh, sorry. There it is. Alright, so let's do it. You ready? So same thing, 1/3 x plus c, negative x plus 8, approaching it from the left and the right to 3. Yep, just like we did. So 2.9 you're going to plug in for x, 2.99, 2.999. And then because you're smart and caught the other one, the right limit is 3.1, 3.01, 3.001. Right? And then I don't know if you have a calculator, but just plugging those in, 2.9 times 1/3 looks like 0.966. And then 2.99. So this looks like 0.996. So it looks like, again, it's going to be 1 plus c. And then 3.1 in the bottom, right? So negative 3.1 is 4.9, negative 3.01. So this one looks like 5 again down here. So it looks like C is 4 again. I don't know. I mean, it's exactly the same as that last one for the answer, but I'm pretty sure. You had a 1-question quiz. Sweet. 100%. I do. I mean, especially. So you have 2 quizzes down or 3 down? 2. You got 2 done? All right. Well, we've done 3. Maybe just do a couple more and sure you're safe. No, it's not sure. Okay. There we go. Okay, yeah, let's check out what it's talking about here. See, I don't limit 6 equals 6 as you're approaching 4. I mean, I don't know what the graph looks like here, so no, I don't see anything. Limit properties. So go down that limit properties there a little bit. The limit of a constant function is the constant itself. So I guess, does that make that statement true? Can you go down a little bit more? I go down a little bit more so I could see that whole example. Right. Okay, so we go back to that practice question. All right. Yeah, I'm not seeing. I would just go back to that practice question. I'm not seeing what you're seeing. So that's definitely true. Yeah. So I'd say true on that one. That arrow means as you're approaching the graph on either side of 4 on the x-axis, but I mean, maybe because that's not 6 down there, maybe that makes this a false statement. So yeah, maybe click false on that one, see, because this is just practice, right? All right, let's see what it said. Alright, so it's true. It's true. Yeah, so ever seen one of those? Yeah. We can move on to the harder ones. So as you plug in the 3 for x, so 9 times 3 plus 8, 27 plus 8, what's 27 plus 8? 35. So that one's pretty easy. I mean, just plugging in 3 and seeing 9 times 3, 27 plus 8. So yes. So 35, just plugging it in for that one. And then same for this, plugging in -5. For x, -5 squared is 25 positive. And then 25 minus 3 gives you 22. So just plug it in once. And this is just plugging in 1, 2. I mean, do you want to skip ahead? Yeah, so it'd be -25 plus 35 minus 8. I mean, these are kind of redundant if you want to skip ahead on some of these. But let's see. So this one's a little harder, where you plug in -6. Plugging in -6 into the top and bottom will give you, what, 36 minus 8 over 6 minus 6, which is 6 plus 6, which is 12. So let me see, 36. That gives me 28 divided by 12. So maybe you could write that as a fraction. That little fraction button down there. 28 twelves. Yeah, I think so. Wait, 4 goes into 27. So 7/3, I think. Yeah. I think that should be good. So again, just plugging in numbers. Alright, well this one's a little different. So we see we have -5. If you plug in -5 in that bottom part, gives you 0 on the bottom. So you're going to have to remember how to factor. So do you see that top part there? I don't know if you can see my work, but I'm going to take that x squared minus 25 and I'm going to factor that into x plus 5, x minus 5. Okay, I hear you. And then if you cross off these x plus 5s, it leaves you just trying to find this piece right here, x minus 5. So if you plug in -5 into here, you get -5 minus 5. That gives you -10. So that's how you find the limit on that one. So that should be -10. But there was one in the video just like that one. Yes. Because it looks like the limit wouldn't exist, because if you plug in -5 on the bottom of that fraction, it gives you undefined 0, which is bad. But that little work that I showed you on the side, remembering how to factor and cross pieces off, it changes the answer a little bit. I can. Yes. So this one's a little bit harder, but you're going to have to factor top and bottom. So I think x squared plus 3x minus 208. I know that bottom part is x plus 13, x minus 13. But -208. So I'm going to do that little diamond method there. So 208 divided by 208 divided by 20. So I'm trying to factor 208. Two numbers at times give you 208. And add to give you 3. So I think it's 13, because -208 is made up of 16 times -13. So if you factor that top part, it turns into x plus 16 and then x minus 13. And then do you remember factoring? Remember doing the diamond method and all that stuff? And this bottom one was a special case. I'm sorry? Add or subtract, be positive 3. So I wouldn't want to make the 16 negative, or I would want to make that positive and leave that negative. And then with those pieces crossing off, all I got to do is deal with this part right here and plug in positive 13 into x. So if you plug in 13 there, you get 13 plus 16 on top of the fraction, and on the bottom you get 13 plus 13. So that's going to give you 29 over 26. Well, it'll give you a decimal. I would just use that. I would use that fraction button right there, just like that. There you go. Ooh, infinity. I don't know. We didn't do an infinity one. Does this have an explanation? Maybe. It does? Sweet. M is 1, N is 1. Okay. Wow, that's mumbo jumbo. A is 3, so A is the coefficient in front of the x term on top. B is the coefficient of the variable term on the bottom, I guess. Yeah. So if you divide it, you get 0.6. Okay. That makes sense. So that looks pretty straightforward. So if you go back to that practice question there, you close that out. It looks like all you're doing is dividing that 2 by that 9 right there. You see that? So the coefficient of the x term on top is 2 divided by the x term coefficient on the bottom, which is 9. So my calculator gives me 0.222. Or if you use that fraction button, you could just write it 2 over 9. I would write that as a fraction. Yeah. Oh no, I'm sorry. Yeah, you're right. You had it. I'm sorry. The directions clearly say write the answer as a decimal. So you're paying attention. And then to the nearest thousandths. So I think you got to do one more 2 there. I think that's what they're wanting. Fantastic. So for this one, just check out the explanation super quick, because it might be just dividing 49 and 13 there. I'm not sure. So yeah, the highest power is x to the third. All right. Divide the numerator and denominator by x to the third and simplify. Can you scroll down a little bit there? Does it let you? Holy crap, you see that? Oh my goodness. Can you scroll up a tiny bit? Right there, perfect. So they're really having you divide everything by x to the third. Alright. Okay, scroll down a tiny bit if you could. Alright, and then continue. I bet they're still just dividing 27 by Alright, you keep going. I'm not sure what they're talking about here. Yeah, let's move on. I don't know what they're talking about. Alright, I bet still they're only going to divide 27 by 36. You watch. Yep, see? Because all those other terms get close to 0 as you approach infinity. Yep. So all that fanciness is another way of saying, again, you should have just divided 27 and 36. That's kind of funny. That's typical. Yep, by just... Well, I think this is typical of like a college way to show a problem. They just show you huge, like long, like justifying what you do, but then at the end they're like, oh, then all you do is divide that 27 by that 36. I mean, if you want, I mean, that is super intense how they did that step by step, dividing by x to the third. And then those little remaining fractions, as x gets bigger and bigger to infinity, those little fractions essentially turn into zeros. So I wouldn't take a picture. No. Yeah. There's probably more things you're going to have to take pictures of. So this one, just 49 divided by 14. So 3.5 right there. I'm not sure. Let's see. Let's see. Ooh, so this one's a little different because you have x squared, they're different powers on top and bottom. So let's see what this says. Let's check out the explanation here for sure. So divide numerator and denominator by x to the third. Okay, you scroll down a little bit there for me. Okay, so they're doing that hardcore work. Yep, the highest power. Okay. And then that divides out. Then you could hit, let's see, it turned into a 1 there. Well, essentially, if you look at it right there, that 1, all those other parts are going to turn into zeros. So you're looking at 0 divided by 1. This is going to be 0. And I don't know if that makes sense, but that limit x, bless you, that limit x approaching infinity means you're plugging in numbers into those x that just keep getting bigger and bigger, like infinity wise, so those fractions turn into 0, if that makes sense. So you could hit continue if you want. Alright, you go down a little bit. Yep, so that's 0, 2, hit continue. And then continue again. Because again, they're just telling you that those fractions turn into 0. So yeah, see how those are zeros there? So that equals 0. Yep, 0. Got it. So you want to nail this quiz, get this quiz done? Let's check it out. Yep, plain old 0. So it looks like this program you're doing, it's making it easy for you. It will explain it enough to you for you to pass this class. And you're probably smart enough to really do all this on your own and not even need me, but probably it would take you longer, but it's up to you what you want to do. I'm always here to help you. So it kind of stalls you. That sucks. You kind of stalled until you figure it out. That's a bummer. Alright, so this one you're plugging in 7. So when you plug in 7 into negative x squared, it becomes negative 49 plus 5 times negative 7 minus 3. So you're looking at that limit is negative 49 minus 35 minus 3. Yep, because positive 5. Oh, you're right. That's positive 7, huh? So plus, thank you. Yep, negative 49 minus 3. So I get negative 17. I'm not sure I got. Because you're right, that plugging in positive 7 makes that positive 35. Yep, plus 35 minus 3. So negative 17. All right. So plugging in negative 6 into x squared. So negative 6 times negative 6, you're right, positive 36. And then 36 minus 2. 34. Yep. So we're gonna have to factor this one, remember? So 196, that looks like a product of perfect squares. I think that's, is that 16? No. It's 14. So that bottom part becomes x plus 14 times x minus 14, if I factor that special case on the bottom, and then 238 looks like it's made up of 17 and 14, so that's going to be positive 17 and negative 14 if I factor that top one using the diamond method. Yep. And I use my calculator, and that's made up of, if I multiply 17 times negative 14, that gives me negative 238, and if I add those, it gives me positive 3. And then looks like the x minus 14 pieces cancel. And then if I take this piece right here that's left, and I plug in 14, it will give you your final answer there. So it looks like on that fraction button you're looking at 31 over 28. I believe that's what that looks like. Yeah. No, that's true, remember? True. Yeah, when we said false, we missed it. It's always true on those. I forget the reasoning, but it's definitely no. They're always true. Yeah, those are true. Yeah, should be it. Good job. So what's the status? What's your status? I don't want you to get dropped. Okay. Sure. Yeah, let's do one more. If you got the energy. Possibly later for me, not 100%. Probably. My mom's been kind of sick. It's kind of a bummer. Yeah, it's a bummer. Not feeling good. All right. These are good ones. I understand these good ones. Okay, so do you see what that A says x approaching 2 negative? Do you see that? So that means you're looking at the graph and looking at positive 2 on the x-axis, and you're coming at the graph from the left. So if you look, that little left part, that little arrow and that little dot, that's the part of the graph that you're coming on as you approach 2 on the x-axis. So if you look, that limit is positive 4 on the y-axis, if that makes sense. And so that would be, A would be positive 4. And then if you look at the B choice, that B says, let's see. Wait, yeah, don't type in that 4 yet there. Oh no, that's right. Yeah, approaching this graph from the left. That's what that little minus means. And positive 2 on the x-axis, approaching it from the left. Yeah, that's 4. And then just trying to explain it to you, do you see that choice B one where it says 2 plus? That means you're approaching from the right. And if you look at that right part of the graph, as you're approaching positive 2 on the x-axis from the right, it hits that little open dot. So if you look over on the left, that limit is positive 1. Does that make sense? And then choice C, that 2 without any symbols on it, that means you're approaching the line from both sides. It's that video that I sent you, I don't know, it really explains this way better than I can. But this one's definitely 4. Okay, for sure. Luke. Yeah, come on. All right. So that one definitely is full. That makes sense. All right, this one B. So, were you following what I was saying on this one? So, approaching positive 2 on the x-axis from the right. You're pointing right at it, that little open circle. So if you look on the left there, that would be positive 1. And then this one, see that 2 without any symbols above it? For this graph, that limit does not exist, because for this to be a limit, you'd have to have that graph not have that gap in it. Because that gap, because approaching 2 on the x-axis from the left, you got 4. Approaching 2 on the x-axis from the right, you got 1. Because those numbers are different, this has no limit. So that's it. Well, for that 2 without any symbols, positive, negative, to have a limit, you can't have a gap like that. So that makes that not exist. And then the last one, you want to go over to 2 on the x-axis and find the solid circle and whatever that y number is. So it looks like that's 4, right? Yep. So that's how you do these. They're pretty straightforward. Not too bad. So let's see. So this one, again, you're looking at the graph, the first one, A, approaching 4 from the right. So do you see what that y-axis number is? So 4 on the x-axis, approaching that graph from the right. So looks like you hit that open dot, right? And then whatever that is on the y-axis, that's your limit. Five. This one, 4 from the left. So approaching 4 on the x-axis on this graph from the left side. So it looks like you hit that solid dot. So approaching 4 on the x-axis, coming from the left side of the graph. That's what that means. So you approaching 4 from the left, you hit right where your pointer is pointing. So that looks like that's positive 2. Yep, for sure. And then, what happened? Okay, so this one here, 4, if you're looking at 4, because those numbers were different, this limit again doesn't exist. You can't have those numbers be the same. The only way for that positive 4 without a symbol to have a limit is if there was no gap, if that graph just like looked like a solid V. I don't know if that kind of makes sense. But because there's a gap right there, this is definitely, that does not exist. Yep. Approaching from the left gave you 2, approaching from the right gave you 5. Those numbers don't match up, no limit at the plain old 4. And again, that video, he explains that much better than I did. And then that last one there says, is f of x continuous at 4? And again, I would say this is 2. I mean, it looks like, because you have that solid dot right there. So I would say A and put a 2 in that box. You might get that one wrong, but we'll see. I was right. Okay. Let's take the quiz. Oh. I would say C, yes, because it's continuous, because at 4 x equals 4. Wait, can you scroll down a little bit there? I would put C on that one. What's it say? Maybe B. I mean, because there's a gap there, there's no limit. Maybe. Yeah. Okay, we got that one now. Sounds good. This new software a little different, but kind of the same. They're all right. Yeah, and you can see they clearly show you how to do the problems easy. Are you taking other classes right now? Man, you're busy. That sucks. I'm sorry. Where are you going? Somewhere exotic? Oh man. Oh man, this sucks. Oh man, it's making me sad. That sucks. Oh well. Yep. Looking forward. I know it's dry. My son's senior year, and I sucky. Well, Nathan, he accepted at Chico State, and they're doing it all online. Yeah, so it sucks. Oh, or last. Ugh. Yeah, what a pain. Ugh. Open. That would be great. Fingers crossed. I'm not seeing what you're seeing yet. Alright, there we go. So you're approaching positive 3 on the x-axis from the left. That's what that first question's asking you for choice A. Yep. So that graph, you could see as you're approaching the graph from the left, and you get to that point 3 on the x-axis, almost like an imaginary line going straight up and down through 3. What's the left side of that graph? What's the y number? Do you see it? So go straight up like that. Go up straight up that imaginary line. There you go, right there. What's that y number right there? Five. So that's this graph showing as you're coming from the left, where does that part of the graph come to that like almost imaginary dotted line going through 3 on the x-axis. It's kind of hard visually to picture it, but that's what that's meaning, that limit. So this one's saying opposite, approach that imaginary dotted line from the right side and see where it matches up on the y-axis. There you go, right there. So now though, you're approaching from the right side of the graph, so you're approaching that part right there where you're pointing, right there. So that's that number right there. What's that on the y-axis? So 0. That's approaching that imaginary dotted line running through 3 from the right side of the graph. It's kind of weird. So that's the 0. And then if you look at 3, because you have that gap again, it doesn't exist. Yep. So that plain old 3 without a plus or minus on it can't have a gap. That for it to have a limit. Like if that solid dot was way down there where that open dot was, then that would have been the limit. And then this next one, easy, just go over to 3 and then find the solid dot number. So that's 5. And then what else? Is that it? Only 4 parts? So question A, approaching 4 from the right side of the graph. So almost like an imaginary dotted line going straight up through 4. So coming from the right side of the graph, do you see it? Well, that would be if you're approaching the graph from the left side. Here, I'm going to try to draw this graph a little bit. Try to show you. Yeah, I'm going to show you what they mean by that. Maybe my visual will make a little bit more sense. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, can you see my graph? That kind of looks like the one that we're looking at here. So this says 4, so that means 4 is what I keep saying is like almost an imaginary line going through 4 on the x-axis. Like this is your limit. That's your 4 number right there. So that first one, when you see that little symbol x, little arrow, 4, and then a little minus up there by that 4, that means you're approaching this graph from the left, from this side, like this. So when I'm coming from this, I hit that graph right here. Do you see where I'm starting to hit this graph right here? That's already graphed. So I'm coming from the left, and I'm hitting that graph, and that graph. This graph from the left hits that dotted line right there at that spot. So that would be 5. That's that one. That's the plus one coming from the right. So that, oh, you know what? I explained that wrong. This is a plus right here. Sorry. Yeah, so that plus means coming from the right side of the graph, coming from right to left. So that's why that X arrow 4 plus, that's why it's 5. And then that X to the 4 minus, that means you're approaching from the left side of the graph like this. So that one wouldn't be 4 though, because that one, when you're coming from left to right, it hits this imaginary limit line right here, but that Y number is 1. Do you see that? So that's what those are meaning there. And then for that X arrow 4 without anything on it, because there's a gap right there, this doesn't exist. But if you look at my graph, if your graph looked like this instead, like maybe did this, like went up like here instead, then that means as I'm approaching this from the left, it's 1, and if I'm approaching it from the right, it hits that at 1 also, so that would be a limit of 1 if the graph looked like that. But because your graph for your question has this gap right here, the number from the left was 1, but coming from the right being 5, that double number being different, that makes that have no limit right there. That's my little explanation. So that's why B would not exist. That one right there definitely doesn't exist. And then this one again, just find the solid dot at 4 and find the Y number. So that's this 1. And then remember we said this one was no. Yeah, because there's that gap right there. I think that's it. That should get you your score. Alright, good job, lady. So I did video this. I don't know if you ever look at those, but I'll send you that link. Yeah. Yeah, what time are you looking at? Alright, I'm either, yeah, we might be busy, but if I'm not, around 4, I'll text you. Alright, sounds good. Alright. Whatever works for you. I hear you. Sounds good. Whatever works for you. Alright, you're welcome, Savory. Get you rolling. We'll talk to you later.